Welcome to another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's series, we're moving into VMware. That's right, we're coming at you with some VMware Certified Professional version 6, and in the studios today with me is none other than Mr. Don Pizzette. Don, how you doing, sir?
I'm doing great, Wes. Ready to dive right in and start tackling our VCP6 content. In this episode, we're going to do a quick introduction, and I know for those of you that have worked with vSphere, it's not going to be exciting. You're not going to hurt my feelings if you skip the episode, but for those of you that are new to it, I think it is really important to understand exactly what VMware vSphere is, what the vSphere suite is, what the components are, and just have just an all-around general knowledge of what the heck is the product that we're about to spend the whole next set of 20 some odd episodes talking about and learning about. So in this episode, that's going to be my focus, is to introduce you to the product line, talk a little bit about licensing, a little bit about the various versions and editions that are out there, and how each one functions. Now, this is testable material, so if you're going to skip it, make sure you actually do know it. Like the difference between a Type 1 and a Type 2 hypervisor is really important on the exam. So those are topics that'll turn up, and we're going to see them all right here in this episode.
So, Don, before we started the episode, we were talking a little bit about vSphere, and you said that there, some people aren't really, familiar with what it is. You going to help us out with that?
All right. So, like I said, vSphere is a suite of software. It's not one particular piece of software. It's several things combined together that create the vSphere solution. And VMware's used this terminology for a while. There used to be other names for it. The virtual infrastructure, VI is what they used to call it. Now it's all just called vSphere. And vSphere 6 is the latest version of it. Now, inside of vSphere 6, there's a number of products. And the most commonly thought of product is, well, like when somebody says the name of the company, when somebody says Microsoft, you think Windows. When somebody says Apple, you think of the Mac, right? Or Mac OS. When you say VMware, people think of the virtualization hypervisor, which is called ESX. Now, ESX, it has a couple of different names that are out there. The official name for it is the VMware vSphere hypervisor. So when you go on VMware's website and you read their documentation, it'll usually say the VMware vSphere hypervisor. But it's had several names over the years, and even on the exam, you'll see where they still use ESX as often as they use the vSphere hypervisor name. So you see it very commonly. But what ESX is the actual virtualization hypervisor. It's the actual engine of this whole thing. So when you have a bare metal server, you've got to install something on it so it can run virtual machines. And ESX is what does that. So that's kind of the key product. And when I hear a lot of people come to me and say, hey, Don, I have a VMware question, or Don, I'm trying to install VMware. Well, VMware is a company. It's not a software package. You can't install it. And what they're normally referring to is ESX. Now, that name, it actually stands for something. It's an acronym. It stands for Elastic Sky X, which is a very, very old name. They used that back in the 90s. It was a long, long time ago. So nobody uses that. In fact, most people, even people at the company, don't necessarily remember that's what it stands for anymore. But ESX originally was created as this hypervisor that's evolved quite a bit over the years. And for a little while, it was branded under a slightly different name of ESXi, which was ESX Integrated. And what you could do is you could actually buy servers back in the day where they would have VMware ESX integrated into a chip on the motherboard so that the hardware actually supported it. We don't need that anymore because now we have virtualization assist hardware built into our CPU. So when you get an Intel CPU or an AMD CPU, it's got acceleration for virtualization built into it. And so now it doesn't matter if we run ESX on a hard drive or a USB key or whatever. It doesn't have to be integrated into the motherboard. So you really get a huge amount of performance gain out of that. And so ESXi was the name for the integrated version. Technically, we are still running ESXi, but it's not truly integrated. So you'll hear people use ESX and ESXi interchangeably, and technically, they're all the same thing. All right. Now, that's kind of the flagship product. That's the main heart and soul of VMware's virtualization is ESX, or the VMware vSphere hypervisor. But it's not the one you're going to be working in every day. It's not the interface you're going to use every single day. It's not what you're going to be touching. You install it, and then you kind of forget about it. And everything else you do is going to be in the rest of the suite of products that are from VMware. So, for example, vCenter. vCenter is the centralized management portal that we can use to control 1, 100, 1,000, 10,000 virtualization hosts and hundreds of thousands of guests. I mean, you can control huge environments. And so we will work in vCenter every single day. It's what you see. That's really the face of VMware. The face of vSphere is vCenter. But that's not the engine behind it. That's not what people think of. So those terms get a little bit blended together. And then there's other pieces that are a mix of it too. We'll learn about vRealize, there's vHorizon, there's all sorts of other different products that are a part of the vSphere suite to serve a purpose, and we'll see them all throughout this series. But the two main products that we're going to be interacting with are the ESX hypervisor and the vCenter server that we use for management. All right, so those are the two key things. Now, let's talk a little bit more about that hypervisor, because I'm throwing that word around like it means nothing, or well, like everybody knows what it means. And honestly, the odds are, if you're watching the show, you probably do know what a hypervisor is. But let's just real quick touch on hypervisors so that you know the difference between some of the different ones that are out there, and you'll be able to handle those test questions a little bit better. All right, now ESX is a type 1 hypervisor. There's two types of hypervisors that are prominent right now. There's actually more, but there's only two that we really care about, type 1 and type 2. And it's kind of funny because the type 2 hypervisors are what came out first, and the type 1 hypervisors came out later, but they're reversed because they didn't have that name back then. And really the type 1 hypervisors are the ones that are good, and the type 2 hypervisors are the ones that are okay. And so we got good and okay. They're not bad, but not great. So the way they work is fundamentally different. Let me start with the type 2 hypervisors. These are the ones that were invented first. Back in the day, if I wanted to do virtualization, right, the core idea behind virtualization was that I could have one piece of hardware that behaved as multiple pieces of hardware. So instead of having 4 separate servers, maybe I could have one server. This used to happen all the time, where you'd have a service like DHCP and DNS and let's say it's a Windows environment. You have the Active Directory, right? So I might have an Active Directory domain controller, a DNS server, and a DHCP server. Very common. Well, all three of those are pretty low resource intensive, right? They don't need a ton of access. The domain controller, it can see a little bit of CPU activity because of its authentication stuff. DHCP, it practically flatlines even on massive networks. DNS, same way, really not doing a whole heck of a lot. So in the olden days, when we had dedicated hardware for everything, you'd be tempted to put them all together. I could have one server that ran my domain services, that ran DNS, that ran DHCP. But here's the problem. Let's say that my DNS server crashed, locked up, something went nuts with it, and I had to reboot the server. Well, that meant that I had to reboot my domain services and I had to reboot DHCP also, because one service failed. We don't have that boundary, we don't have that separation. So they mix together, and that leads to problems. If somebody hacks their way into my DHCP server, now they've got access to DNS and Active Directory also, right? So I have all sorts of blurry lines in between these software applications. That's a problem. So the solution was to buy 3 servers, to buy 3 physical servers that we knew Active Directory wasn't that resource intensive, and we knew that DNS wasn't, and we knew that DHCP absolutely wasn't, but we separated them anyway. We bought 3 pieces of hardware. And that hardware, for the most part, went way underutilized. If you look at servers today, if you go to HP or Dell, Lenovo, wherever it is you go to buy a server, and you buy the cheapest server they've got. I mean, you go super budget, right? 1 power supply. What's the minimum cores you can get these days? I don't even think you can get a single core processor anymore. Can you?
No, I think it's 4 in the servers. I'm gone at 8 and beyond now.
Yeah. So let's say you can find a 2-core CPU, right? And what's the minimum amount of memory we can even buy these days? Maybe 2 gigs of RAM. So if you get something at the very, very rock bottom, and you throw it up as a DHCP server, right? Maybe it's a Linux DHCP server. It's not going to use even half of that, right? It's going to be wasting those resources, and there's nothing you can do about it because that server is dedicated to do DHCP. So the idea behind virtualization was, what if instead of that being a physical server, it was virtual, it was fake, it was a fake server. And DNS could have a fake server, and DHCP could have a fake server, and Active Directory could have a fake server, but all 3 of them would run on the same hardware. And if I needed to reboot one, I could. If I had to do a patch update on one, if one got hacked into, that was fine. It just affected that. It wasn't fine, but it just affected that one. It didn't affect the other ones, right? That is kind of the goal of virtualization. It's like carpooling, right? I drove to work today in a car that has, how many seats do I have? 5 seats, 6 seats, right? 6 seats if you're really friendly, 5 seats if you're not. I was the only person in the car on the way to work today, right? So all those other seats were empty. I completely wasted it, right? Well, nothing I can do about that. I didn't have extra people to stick in there. But what if I did, right? What if I carpooled? What if I had a few friends, I chucked them in the car too, and we all just happened to be going to the same place? Now I've increased what my car was able to do, right? And that's what virtualization can do for us. The trick is making it happen. And so in the early days, they had an idea, and it wasn't the most graceful idea. It's what is ultimately now a type 2 hypervisor. And they said, well, if we need 3 fake servers, or however many fake servers, then we're going to need fake hardware. We're going to need fake RAM and fake, I keep saying fake, I should say virtual. That would be a little more technically accurate, I guess. We need virtual memory, virtual hard drive, virtual network adapters. We need all this fake stuff. And so they built an emulator. An emulator is a software application that creates the image that something exists that doesn't really exist. So, for example, there might be 2 gigs of RAM that doesn't really exist. That I've got 16 gigs in my laptop, but I slice out 2 of it and make it a pretend 2 gig set of memory, right? And I might have a CPU of one type, and I create a fake CPU of another type. And we create all this fake hardware. And then we present it to the virtual machine. And the virtual machine sees that hardware and thinks it's real. It says, oh, look, there's a hard drive for me. There's some memory for me. There's some CPU resources available. This stuff is available for me. I'm going to use it. But every time it goes to use it, it's fake. And so what we have to do is intercept that call and turn it into a real call. Let me show you on a diagram. It'll make a little more sense. So I've kind of diagrammed out here a type 2 hypervisor. And what you're seeing is a few different components. Way down here at the bottom, right? So way down here, we've got the server hardware. So I go out and I buy a physical server, and it's got CPU, RAM, network, disk. It's got all the different components that we buy and put into a server, right? And in order to get that server to do anything, I have to install an operating system on it. So I install an operating system. And maybe that's Mac OS, maybe it's Linux, maybe it is Microsoft Windows. It's whatever operating system I choose to stick on there. But that operating system has direct access to all of this hardware, right? So let's just assume it's Windows. And so if Windows wants to access the CPU, it does. If it wants to access the RAM, it does. It just reaches out and grabs it. It's got exclusive access to this hardware. And what the operating systems do is they use what's called a HAL, a hardware abstraction layer, that is what's actually talking to all this hardware. And the host OS has exclusive access to the HAL. The HAL has exclusive access to all the hardware underneath it. Exclusivity is the key word there, right? It's all tied up, and only this one machine has the access. Now, if I have a type 2 hypervisor, I install that on the host OS. So here's the type 2 hypervisor that we're installing right on top of that host OS. And it's got management software. Management software is installed right on top of the host OS also. So this is a program that's running right on top of the host OS, right? Examples of the program, VMware Workstation, which you can still buy today. VMware Fusion, which is very popular in the Mac world. Parallels also in the Mac world. Oracle VirtualBox, which will run on darn near every OS. What are some of the other ones? VMware used to have a server product called VMware GSX, which now they call VMware Server. I'm not sure if they still sell that or not. They might, but all of the products that I just rattled off, those are all type 2 hypervisors. They work exactly like you see here. So you install a host OS, and then on top of that host OS, you install whatever that type 2 hypervisor product is, right? Let's just say it's VMware Fusion. I'm running that on my laptop right now. So I install VMware Fusion. Well, then what VMware Fusion does is every time you create a virtual machine on it, it creates a fake set of hardware, a CPU, RAM, network, disk for this guest OS, and then CPU, RAM, network, disk for this other guest OS. And I might have an Intel network adapter in my computer, but when that virtual machine fires up, it might see some kind of super generic Realtek network adapter or something like that, right? And it sees whatever the virtualization software makes it see. That's what it picks and it puts in place. I might have a wireless adapter on my laptop, but this virtual machine sees it as a wired adapter because it's fake. It's not even a real adapter, right? It's a virtual adapter that it creates. And so when we bring up that guest OS, we've got to load drivers and all that so it recognizes this hardware. That's not such a big deal, right? That actually works pretty well. We install our applications on top of it. Each of these guest OSs thinks they have their own real hardware and they run just fine. But the challenge comes in with performance, right? anytime one of those applications goes to access something, right? So if I've got an application and it needs to access the, we'll say the disk, right? So it's, that is exactly not what I wanted. It's going to go in and it's going to access that disk. Now, when it goes to do it, it thinks that it's writing to a real disk, okay? But it's not. It's writing to a fake disk. And that fake disk, well, it's fake. So that call gets sent down to the fake disk. Our type 2 hypervisor has to intercept it and take that disk call and turn it into a real call. Now, our virtual machine might be seeing this disk as a SCSI drive or a SATA drive, but under the hood, we might have the opposite, right? This might be showing as a SATA drive here, but we have SCSI drives on the back end, or vice versa. This is very, very common. And so what happens is the type 2 hypervisor has to take that, and then it's got to convert it. It's got to convert it from whatever type of call that was to whatever type of call our real disk needs. And so that little communication is coming from the guest and getting converted. And you probably see where the problem here is already. We have to do a conversion for every single thing. Every time we talk to the CPU, every time we talk to the network adapter, every time we write to the disk, every time we touch RAM, there's a conversion. And as a result, you take a performance hit. Type 2 hypervisors are not as fast as true hardware, right? When we say true hardware, we normally call it bare metal, like the actual metal servers, not virtual stuff, but real metal that's sitting there in a rack costing a lot of money. So that's the problem with type 2 hypervisors. And I say it's a problem. It's only a problem if you don't plan for it, right? If you went into this thinking it was going to be great, then yes, this is a problem. But if you use it where it's intended, maybe you have labs that you want to set up, like I do here on the show all the time. I bring up virtual machines to show I can use a type 2 hypervisor, works fine on my laptop. I wouldn't want to push it into production. But for lab and R&D, type 2 hypervisors are super convenient because you can just fire them right up on top of your own OS, and now you're in business, right? So I paint a bad picture about type 2 hypervisors. They're not bad. They just have a purpose. And their purpose is not to be used in production. Their purpose is to be used for lab, research and development, testing, simple application support on your own workstation, that kind of stuff, right? It's not designed for you to run your web farm out of it. That would be bad. There's companies that have tried it. Microsoft. Do you remember, what was Microsoft's virtual server called?
Yeah, Don, I think that server, that was Virtual Server 2005 R2, I believe.
That's it, yeah. So Virtual Server 2005, that tells you how long ago this was, right? It was 11 years ago. So not a great product. And Microsoft, they had bought, I think it was Connectix was the company, and what the mistake was is they had this type 2 hypervisor they pushed for production use, and it just really wasn't suited for that. So they ended up scrapping that and creating Hyper-V to replace it, which is their type 1 hypervisor. Now, even back then in 2005, VMware had a type 2 hypervisor and a type 1 hypervisor. That's really their claim to fame. VMware is really the company that is responsible for promoting type 1 hypervisors and getting them to be what they are. So let's talk about type 1 hypervisors real quick. Now, in my diagram, I showed you guys a type 2, right? So if we just kind of relook at that, the big problem was an app sends a call to virtual hardware. The virtual hardware then has to get translated and then sent to the real hardware. So we're emulating fake hardware, and that's where our performance bottleneck happens, is right here in the type 2 hypervisor, all right? Well, let me show you a diagram I made of a type 1 hypervisor. First thing you're going to notice is it's a lot more simple, right? Type 1 hypervisors are a lot more clean in the way that they work. You still have your server hardware down here at the bottom. So there is a physical machine that you buy, CPU, RAM, network disk, right? That's all the same. But then look what's installed right on the hardware. Not the host OS, but the type 1 hypervisor. The type 1 hypervisor is also sometimes called a bare metal hypervisor because it's installed right on the bare metal of the server. I don't need another operating system. I can install the hypervisor right here on the hardware. And then the host OS is actually installed on top of that hypervisor. The host OS is technically a guest. It's technically a virtual machine because it's running on top of that hypervisor. That means that it doesn't have to get in the way anytime a guest OS wants to access hardware, right? Because the host OS is not in between the guests and the hardware. It's just the type 1 hypervisor. And the way the type 1 hypervisor works is it doesn't have to emulate hardware. It can directly expose hardware if it wants. So it could take the CPUs and just let the virtual machine see the CPUs directly, not an emulated CPU, not a fake one, but the real actual CPU. And then the Type 1 hypervisor can just act like a traffic cop and say, all right, this guest, it's your turn, now it's this guy's turn, now it's that guy's turn, let me go back to this guy, and oh, you're taking too much time, so I'm cutting you off, and works like that, right? It controls people's access to make sure that everybody gets fair access to the hardware, but otherwise, everybody is able to directly access the hardware. Now, it doesn't always happen. You'll notice, for example, later on in the show, when we start creating virtual machines, that we do have to load drivers for VMware, and that things like the network adapter, I might have an Intel Pro 1000 or something like that, right? The virtual machine might not see that. The virtual machine might see a VMware network adapter, a VMNIC. And that's because VMware actually has these little accelerations. And so they can create an accelerated virtual network adapter that runs faster than if we were to allow the machines to directly access the adapter themselves. If they were allowed direct access, every virtual machine would see the packets that were coming in, and they would then have to figure out which packets were theirs and which packets were somebody else's. Well, what happens when a server gets packets for somebody else? It throws them away. We don't want that. We want the other machines to get it. And so their virtualized adapter actually works better than the direct access to the hardware. So even though we can have direct access to the hardware, it's not always a great idea. You'll find that RAM and CPU, they do it, and disk even, if you've got the hardware support for it, these virtual machines can be allowed to directly access the disk, and now you get actual wire speed communications. No translation, no emulation. This is much faster, much more stable, and now it's something that can be used in production.
Don, is the Type 2 hypervisor, it seems like there's a couple of layers of translation or abstraction going on. So not only does the the guest operating system have to make a request to the hypervisor itself, but then the hypervisor has to make a request to the base operating system. Is that one of the reasons, you know, that it does slow down the performance versus the Type 1 where there's not a second layer?
Yeah, I mean, even if it was identical hardware, right? If the virtual network adapter was identical to the physical network adapter, it is still two calls, right? And so there is going to be a slowdown there. But it's rare that those two match. And so it's almost always a call to one fake type of adapter that then has to be changed to match the other adapter, and that makes it even worse, right? And so when we deal with that Type 1 hypervisor, that gets cut down. That now we can see the real hardware. Our call is already in the right format. It gets sent along. There's no translation at all, and it's one step. It really is wire speed or near wire speed. It's very, very fast. And that makes Type 1 hypervisors really attractive. And that is what the VMware vSphere hypervisor is, right? The VM visor, as they call it sometimes, is a Type 1 hypervisor, and it runs really, really well. Now, here's the problem. You might be saying to yourself, well, Don, I'm having a hard time seeing when I'd ever want to use a Type 2 hypervisor here. Type 1 sounds so awesome, depending on how you think, I guess. But the problem with Type 1 hypervisors is they expect that hardware to be dedicated for these virtual machines. Remember how the host OS is running as a virtual machine? And so the challenge here is that most Type 1 hypervisors don't have a user interface. So if I were to install ESX on my laptop, I would boot it up, and a screen would pop up saying, browse to this address to manage the server. And that's it. I wouldn't be able to use my laptop anymore. I'd have to go to another computer to remotely connect to my laptop to be able to use it again, right? So if this is some kind of multi-purpose device like my laptop, I don't want a Type 1 hypervisor. I want a Type 2 because I can still run my host OS and then turn the hypervisor on and off when I need it. Now, some vendors have tried to blur the lines on that. Microsoft is a great example where their Hyper-V product, you turn it on, it is a Type 1 hypervisor, but you run the host OS right there on the local screen. But they eat up a ton of resources by doing that. It's not an efficient way of doing things. With VMware, they want you to get the most bang for your buck, the most hardware resources available. So with ESX, it's actually running SUSE Linux, it's a variation of SUSE Linux. It's not true SUSE. So it's running Linux under the hood, and the base OS fits in a footprint that's like 600 megs in size, very, very small. They basically took Linux and stripped all the GUI stuff out. They stripped out any feature you didn't need and left it with the bare minimum to have that system up and run and be network manageable. So you get the most full use of your resources on the system. And we'll see that as we start creating virtual machines, that we can really get a lot of utilization out of our systems. With other products that are out there, you don't necessarily have that. So just be aware, some of them do work a little bit differently. But what I've shown you here is basically how a Type 1 and Type 2 hypervisor function. And that ESX piece, that's our Type 1 hypervisor. All right, now those are just some of the components inside of vSphere. So we talked about ESX, we talked about vCenter a little bit. You'll see that like if you go to VMware's webpage and start shopping around, that things can get really confusing really fast, right? I mean, just look at these menus and how many items we have up here. VMware makes a lot of stuff. And some of it is really, really great stuff that a lot of companies use. Some of it is really, really cutting edge fringe stuff that not many people are using, but it's the future. Some of it is extremely specialized stuff that unless you're in one particular market, you'll never ever use, right? But the main product suite is vSphere. And when you purchase vSphere, it comes in several different editions. And so I just want to run over those really quick, what the different editions are. Now on the website and on the exam, they really only highlight 3 primary versions, these 3 guys right here. But in real life, there's probably 6 or 7 different editions of vSphere that you can run into. On the exam, they want you to know these 3. You've got vSphere Standard, vSphere Enterprise Plus, and vSphere with Operations Management Enterprise Plus. All right. Now, what these basically do is have an increasing feature set. You get more and more features with each one. vSphere Standard, that's the basic standard implementation of vSphere. It gives you a Type 1 hypervisor, it gives you vCenter to be able to centrally manage it, and you're able to control those systems and work with it up to a certain amount. And so basically a standard vSphere license gets you a license based on CPU. Now that's important, I guess. It used to be that you were licensed based on how many physical servers you had. But as more and more cores started getting introduced, people needed less and less servers. And so it wasn't a good licensing model for VMware. So they changed it, and now you're licensed per physical CPU. So if you have 1 physical CPU or 2 physical CPUs, that's what you have to pay for as far as your licensing is concerned. And so the standard edition gets you centralized management and a Type 1 hypervisor to be able to run your virtual machines. And that's what a lot of people need. But if you step up to the Enterprise Plus, Enterprise Plus is where you start to get a lot of extra features. Some really impressive stuff gets baked into it. In the episode notes, I'll put a big list. Actually, I'll put the link to this page too, because they really lay it out here. There's a ton of stuff. But the key differences, there's a lot of features here like vMotion that are present in all 3 editions, right? vMotion says, I can take a virtual machine running on 1 physical piece of hardware and move it to another piece of hardware without rebooting the virtual machine. It can stay on and operational the whole time. It's really cool. We'll see it later in the show. But that's vMotion, and it's present in all 3 editions. So it doesn't matter if I have Standard or Enterprise Plus or whatever, I'm going to have that. But when it comes to differentiation, Enterprise Plus starts to bring in all of these extra guys right here. Reliable memory, where it can have multiple copies of memory and identify when a fault occurs. And if a fault occurs more than once, it can blacklist an address of memory and stop using it. It's pretty neat stuff. So it'll be, I don't want to say redundant, but more like resilient in the event that some kind of memory failure occurs, it'll keep running. Big data extensions, if you're doing Hadoop clusters or anything like that, it's got support for it. Some of the other ones, the distributed resource scheduler, this one's pretty awesome. We're going to see it in an episode later on where we can schedule to balance out our virtual machines. So if I have 1 physical piece of hardware that's starting to get a little oversubscribed, I got too many VMs running on it, and I've got another piece of hardware that's sitting there idle, I can move some virtual machines over and balance it out, and we can have it automatic. The DRS lets you make it all automated and stuff. Is pretty cool, neat stuff to have. Storage I/O and network I/O controls, so you can throttle virtual machines. You don't want 1 VM eating up all your network or 1 VM eating up all of your storage. With storage, we're talking about disk I/O, right? The input and output. Or maybe you do. Maybe you have a database server that you want to run as fast as possible, so it needs priority for memory and disk access over everybody else. So you can come in and you can configure the I/O throttles for that. The I/O virtualization, that's for the wire speed disk access. You have to have hardware to support that, and the Enterprise Edition is what lets you enable that. So you'll see a bunch of features like that, distributed switch and so on. A lot of ones we're going to talk about in the show that aren't present in Standard Edition that you have to have Enterprise Edition for. So when you go to buy vSphere, you got to make sure you pick the right edition, because if you know for a fact, I need a distributed switch, I want to make sure that I've got full network redundancy and that I can have VMs on any of these hosts and they'll all be on the same network, you need distributed switch. It's not in standard edition. So then if you go out and buy standard edition and you go to set up a distributed switch, it's not going to work, and then you got to go and buy more licenses and you blow your budget. So just be aware that as you go to pick it. ESX under the hood is identical. vCenter under the hood is identical. It's just certain features won't be able to be turned on. So the actual operating system and stuff is the same. The performance level is the same. It's the bells and whistles that make the big difference. And it can be expensive. Now, the big difference, though, is this last one right here. So this one was vSphere Enterprise Plus. Here it's vSphere Enterprise Plus with operations management. Okay, what is that? Well, operations management is a centralized management suite. It's part of vSphere. It's part of the vCenter server. And it lets you control not just one vCenter implementation, but more than one vCenter implementation. You could have multiple data centers around the world and manage them all together and monitor performance. And you can do things live in real time. If you see CPU utilization starting to go up on your servers in France, then you might take some of those VMs and move them over to your data center over in Germany, where you've got extra resources. So you can start doing balancing across those environments. You can have disaster recovery that happens automatically. One location fails, the VMs spin up in another location and you're back in business. The operations management suite is amazing. It's really packed full of just an amazing feature set. It takes a lot of planning, a lot of implementation effort, but it really is amazing. And it certainly costs a bit more. You got to pay for these things, but what you get in return is pretty impressive. So if you're a small or medium business, that's probably not for you, right? It's probably gonna blow the budget. But for an enterprise, every moment that you're down, your company is losing money. So investing in extra software like this really does make sense, and it's impressive stuff. But like I said, I'll link to this page in the show notes so you guys can see it. For the exam, they do want you to know these three main versions, right? The standard, Enterprise Plus, and then the Enterprise Plus with operations management. But if you look on the website, you'll find where there's other versions, like vSphere Remote Office Branch Office Standard or Remote Office Branch Office Advanced. And you'll see that these support up to 25 virtual machines and come with vCenter. These are designed for small environments. If you're a small or medium-sized company, you might want to go with these, and they've got restricted features, right? This is designed to support just one office, not more than one location. So now you just have one data center. If you start looking down, you'll see some of the other ones. Let's see, where are they? Here, the Essentials, right? So vCenter Essentials, these are really small. So if you're a company that just has 3 virtualization hosts, then you can get the Essentials kit, and it's the lowest price. It's like a low point of entry for getting your feet wet with VMware. And so you can get in there with vCenter, and it's vCenter Essentials, so it's kind of a limited version of vCenter. But you get the hypervisor. You can have up to 6 processors, 3 servers with 2 processors each, or you could actually do 6 servers with 1 CPU each, but good luck finding that. So you've got that one, and the Essentials Plus kit, which bumps it up a little bit more, so you get some extra stuff. You get vMotion, high availability, data protection, and so on. So while these won't show up on the exam, they will show up in real life. If your company is just starting to dabble in VMware vSphere, you can get one of these Essentials kits, and it reduces your risk, right? And it lets you get the software deployed, see if you like it, and then you can expand and grow from there. Now, on the pricing side, I don't normally like to talk about pricing on these shows, but VMware is really transparent about their pricing, and I'll post the link to this page. You can jump over to, it's vmware.com/products/vSphere/pricing. And when you jump over to it, and most of the pricing is in US dollars, so you might have to convert it for your currency. But these are full retail prices. You can usually get it a lot cheaper. Like if you buy it through Dell, you get significant discounts. But you get an idea of how the pricing works. And so when you look at like vSphere Standard, it's about $1,000. vSphere Enterprise Plus, $3,500, right? Significantly more expensive because of the extra features that you get. But the jump from there to operations management is actually not that high, and so you can make that jump to get a little bit higher. They do have subscriptions for support. So if you have a problem and you want to call VMware for help, you need to have a support subscription, and that's an annual fee, and those are priced pretty reasonably. And then you'll see those branch office editions down here, which are less expensive. And do they have the Essentials kits? Where are the Essentials? They don't have it, do they? Yeah, well, here's like vCenter Standard Edition. So you can get all the pricing though right here. It's all pretty well laid out. They do have these acceleration kits, which are designed to really get a company started. It's supposed to have everything that you need based on what it is you want, right? Do you want server consolidation and no downtime? Do you want policy-based automation? Do you want policy-based automation with proactive operations management? You pick, and then you have a price. And these are basically starting points for you. So VMware is not cheap, right? But it's because they're the best. That's how it works, is that, yes, I know I can go out and I can do a bunch of Linux boxes running Xen for free. But I'm not going to have the support on the back end, and I'm not going to have a lot of the bells and whistles that we have here, the automation. Automation becomes very difficult with the open source products. They work really well, but it takes a lot of work to get that in place. With VMware, it's all there, and we've got the support infrastructure. So that's kind of how we're able to justify it for our IT budget, for our line items, and get that going. But those are some of the different products that are out there. Again, for the exam, just remember, Standard, Enterprise Plus, and then the With Operations Management Suite. Those are kind of the three big differentiators that you have when you go to purchase vSphere. All right, Wes, I think that is a pretty good rundown of everything that we need. There are other products in addition to what we've seen here in this episode. I focused on the ones that are on the exam, but just know in real life, oh my goodness, there are so many ones out there like vRealize, VMware Horizon, just so many different ones that provide different functions. Like if let me just go back to VMware's webpage. If I just float over products, right, we'll see the big blowout of all the different items that they've got. And some of them are pretty neat. Some of them you may never need. Like vRealize has some really, really useful stuff for cloud management. If I have those multiple data centers and they're kind of separate, we can actually tie them all together with vRealize. The cloud suite does part of that also. You got Horizon, which is for desktop virtualization. So you might have all of your employees have thin clients instead of full-blown computers, and they're able to access their desktop hosted on a VMware deployment somewhere. Or even from their iPad, they can pull up their Windows machine right there. They don't actually need a full desktop. Other ones, like their identity manager for making it easier to authenticate, have one username and password everywhere you go to. NSX is their software-defined networking suite, which is really impressive, also really expensive. And some of the other things, you'll see they've got a whole software-defined data center. That's a big initiative that's going on right now. These are all different products that all hook into vSphere. vSphere is that umbrella product that when you do a deployment and you go all in with VMware, you're becoming a vSphere data center, and all these components hook together, and you manage them all right from vCenter. It's impressive stuff.
Don, we appreciate that introduction to vSphere. Hopefully it's eliminated. If you have any confusion on it, it's good that you were here to help us on that. Do you have anything else? Because it does look like we're coming to the end of another episode.
Yeah, I'll post the links to this in the show note. Definitely check out VMware's website, read through the stuff, understand the different products. Because in real life, it's all the time where I'll ask somebody, hey, what do you use for your hypervisor? And they'll say, oh, I use VMware. And I'm like, well, okay, all right, I know what you mean. I know that you mean that you use vSphere and ESX. I know that's what you mean. But VMware has more than one product, so maybe they mean VMware Fusion. Maybe they mean VMware Workstation. I don't know, right? Because they just said VMware. On the exam, they'll be very specific. They'll mention those products. And so you need to know what role each one performs. And if you watch this whole series, you're going to see it anyway, so you'll get a good grasp of that. But don't be one of those people that says, I run VMware. Because that means that you're the CEO of the company, right? You don't run their company. You use some of the software products, and the software products have a name. So we just need to make sure we know those.
Well, Don, we thank you for having that information for us, and we appreciate you, the viewer, for watching. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.